As said, I'm Benedetta Ravicchio, and I'm a computational designer and data scientist in Arup. And I'm very happy to be here because by background I was a facade engineer, so I'm very happy to see the outcomes of this research. And just a few words about, for the ones who don't know who Arup is, I put some figures in this slide. So we are basically a firm of engineers and architects working pretty much around the globe, so we have offices in most of the countries, but I think the most relevant figure here is the number of projects. So we currently have 17,000 projects currently ongoing, and our commitment is basically to bring our clients in a journey with us. So we are trying to bring digital in most of the projects when we found some, let's say, enlightened clients that want to be visionary in a sense, and also we are trying to push the attention of our clients to the impact their project have on nature. Our way of working follows the principle of the key speech of our founder. So back in 1970 he wrote the speech where it was talking about the total architecture. So a way of working where all the disciplines create a synergy and work together in order to deliver a better project to our clients. And as a computational designer, I'm part of the digital team. So I would say that our fun part of our job is basically that we work with all the teams. So even though I'm not an ecological specialist, I had the chance of working with the landscape team and knowing about animals' behavior and whatever. And it's always a nice journey because we try to develop new technologies and new tools in order to bring clients. In order to, let's say, bring the digital into the project. And okay, that's why. Okay. So the project I'm about to talk today comes from a synergy between the digital team and the landscape team, and some clients that want to explore the biodiversity of their project. And that is really, I mean, we have a figure here, so the nature is in crisis basically, and there is most of the drivers of the change of this, the aspect of the loss of biodiversity can be related to the built environment, to the way that we are exploiting the lands and the land use. So we wanted to bring some value to our project, and also I saw this figure and this picture in another presentation today, but let's say our commitment as well is to bring some positive impact on nature in our project, and is basically we are trying to bring the client with us in this journey. And from all of this point of view is where I was born. IVE is basically a data-driven methodology, I would say, data-driven approach to design nature-inclusive spaces. And it works basically at all scales. So we started working on a larger scale, so from municipalities, so working on, let's say, neighborhood or a city scale, in order to plan the intervention on the city, plan interventions on the infrastructure, but we can also work on the buildings, both existing and new ones. And I've worked with a few drivers. So the first one is a knowledge to diversity, so understanding that each species, each type of vegetation, as we saw today, has its own needs, and also some preferences about their preferred habitats. So we wanted to understand which were the drivers and which were the needs of the different type of species. And the second driver is basically to understand what is meaningful in terms of vegetation. So it's not just adding green because we need to add green. We need to show that we have plants in our project. It's basically to understand where to put the plants, where it gives an opportunity. So when we have an untapped opportunity and we can exploit our environment. We wanted to explore the relationship between the vegetation and the greenery that we put in our project and their impact on facades and on the buildings and vice versa. So we know that the adoption of plants can be beneficial in terms of improving the comfort in the spaces, but also the shape of our buildings, the way they are designed, have an impact on the vegetation. So we wanted to address the mutual relationship. And the fourth one is basically to try to increase the connectivity, so the ecological connectivity. And as I was saying before, the tool works also at municipality scale, so at larger scale. So we wanted to understand if there were some blockers that, let's say, block this different species to move from one side to the city up to the other. And so I've worked at different levels again. So when we have, let's imagine that we want to work and we are working in a site. So we need to understand what we have in the surroundings. So how much our site is connected to the other landscape and to the other habitats that we have. So we want to improve the connectivity of our plot with the surroundings. We are working on site scale, so we want to increase the habitat quality to make it more, let's say, appealing for the species to live there. And then also we may want to have some intervention, so add some nest or in order to increase the habitat quality in the area. And I would say that this is, from a computational designer point of view, the most interesting part of the project, because basically we define some models. Let's say that we are in a preliminary stage of design, so we try to bring some new metrics into the way that we approach the preliminary design of buildings. And we try to translate all the knowledge of different type of specialists, from animal behavior specialists to landscape designers to building physics specialists. We try to build some models that could work together and that could, let's say, give some insights to the quality of the project. So we basically have a connectivity model that relies on GIS data or satellite imagery according to the availability of the data that we have. We have some vegetation model, understanding how the different plants and vegetation react to the different type of conditions, which is really related to the abiotic suitability model. So understanding how all the physical aspects like wind, sun, artificial lighting and whatever have an impact on the habitat that we are considering. And the fourth one is basically the addition. So what happens if we put some nests or we put some extra elements. And combining all those models together, we had a score for each ambassador. So we identified the 10 different type of ambassador, and the grouping may seem strange if you look at, so there are some coupling and groupings that are quite strange, but we learned from the specialists that is not related to the physical and dimension of the animal, but it's more related to their expectation on the habitat, so how the habitat should be the perfect one for them. So it's more related to their expectation. And we actually started applying this type of model to an existing building. So we had as a client the Harbour Bank in the Netherlands, and they wanted to make their building with more greenery, so trying to have an intervention on the greenery, especially on the roof. So in that case, we had the chance of testing this type of methodology that at the beginning was just an internal research. We had the opportunity to test the methodology, also considering some of the data were already there, so we could have some surveys and we could test the goodness of the data and on the simulation that we were doing. So a part of the model and the score was coming from the 3D map and the generated 3D model. So we run the physical model, again, wind, solar analysis, noise, and also the people in the area, and we get let's say, a theoretical score. And then we went there and we had some surveys, also understanding the quality of the terrain and the quality of the soil. And then we got a vegetation score. So we combined them together and we used those information to try to develop and to try to work with intervention that we were planning. So as you can see here, we have some results about the abiotic model score, and it's not very visible, but the greener scale that you see is basically the biodiversity for each type of ambassador. Then we did the same for the terrain and the soil quality, and we combine all those information together. So you can see that from having all green in some simulation that we are getting to a very low biodiversity score. And that was also interesting because from what we knew and also the way we did landscape design in the past, as you can see, our first idea was to put the vegetation there in the green circle. And then after combining all those information together, actually that was not the best position to place that type of vegetation for that type of ambassador. So basically it was a little bit moved towards the right-hand side of the plot. And we did the same for the different ambassadors. And also that part was a good, I would say, a good opportunity to have a discussion also with the client. So since, as you can see, the Rabobank building is basically a glass box, so also in terms of artificial lighting, it has quite a huge impact on some animals. So they were, let's say, worried about the presence of the lights. So we also could give some insights to the owner of the building about the amount of artificial lighting and maybe the need to reduce that in order to promote and to be more appealing for some species. And here there was a demo, of the very first model that we created for the client. So basically you can switch between the different type of animals and the species, and also on the different type of parts of the building we want to work with, and seeing the change in the biodiversity and the change in scale. And the results were quite good in a sense that there was very much room for improvement. So it was possible actually to bring inside some animals like the hedgehog, which was not an animal present in the area, so it was there was a potentiality to attract them, but there was also potentiality to increase the presence of some of the animals in both of the buildings, because it was two buildings. One was the tower and the other one was the mirror building. And after this, what we say, success story, so that was a little bit of nice work. We had the chance to have a visionary client that asked us to work with the envelope and to create a new design of a building where the nature and the biodiversity could be a driver of the design. So everything was related to the presence of plants and vegetation and different type of species in the envelope. And so the first part of the project was basically to try to understand and to try to identify some microhabitats for the different species. So that was a guide from a more traditional approach, I would say, so trying to understand which were the environmental conditions on the site, sun, wind and water, and trying to understand which were the basic conditions of the habitats. And then starting from then, we started to write new, let's say, new algorithms and new scripts to try to bring together all the metrics. So as you can see here, the shape is quite similar to the valley. So the principle was quite similar. So we tried to vary the cantilever and the balcony dimension, and that was, so in a unique model we were trying to assess the different type of vegetation that we could have, and also for each type of vegetation, also which was the load on the structure. So of course, if you have a larger cantilever with a tree, that will have a different impact on the structural model. So also the structural model was there. And the other interesting part was basically to see how the different type of species and also the seasonality of the species were having an impact on, for example, daylight and natural light availability, passive cooling and heating. So, as you can see here, we try to collect all of these metrics together to have let's say a data-driven approach to the project, so you can see that you can change the dimensions of the balcony. That itself as a background of which type of species we could host, because there was an activity in data in the background. And so according to the different type of species that we can have enlarging the balcony, that could have a different impact, in this case, in the sunlight hours availability on the different areas. So, and also it was important because when you are trying to bring client within this type of journey, it's crucial to give some data, so giving some figures. So just saying that we are adding vegetation was not enough, so we wanted to show with some numbers also how that impact on some metrics like energy consumption, daylight availability. So that was, let's say, a proof of the goodness of the design. And to conclude, as I was saying before, the connectivity and the landscape are playing a crucial role. So if we want different species to move in the city, we need to avoid the fragmentation. So what we are seeing, that if we are building our building in the middle of a concrete jungle, then we cannot expect some animals that basically are moving from tree to tree to come to our place. So it's important to understand the connection of our site with the surroundings. And so we try to understand which were the different type of corridors that the animal could take to come to our potential site. So we have the green corridors, the brown ones, so going with the soil, the ones going with the water, and also the black, so the one taking into consideration the absence of light. And again, we try to work with our ambassadors and trying to understand also, according to the behavior of the different ambassadors, which were their habits. So we know that there are some animals that are more willing to move and they move faster, and there are also some other animals that are basically staying in the same place or just moving very slow. And also we were trying to understand, using the satellite imagery, which could be the barriers for each ambassador. So if there were some parts of the city that were like a blocker for the ambassador to move across, and putting together this information, we could have list cost or score, so basically the shortest path for each animal moving from their original site to another habitat, and also the one with the less barriers. So if I were a squirrel and in the city of Utrecht, if I want to move from one habitat to the other, we can see which are the most likely routes that I would take. So as we can see, the very red lines are basically the highways, and you can understand that a highway for a squirrel could be very dangerous and probably cause the death of the squirrel. So we were trying to understand with satellite imagery which could be the routes that the squirrel would take to move from one habitat to the other, and identifying the corridors for them to move. And that was actually a nice discussion that we had with the municipality of Utrecht, since we saw that, for example, that the rail was intersecting most of the ecological corridors. So we started to define some actions and some interventions with them in order to bring back these ecological corridors entirely without having some blockers and without some obstacles. And that was quite useful because we could understand and we could give some prioritization to some interventions rather than the others. So it was a very interesting discussion with them, and that's all. Thanks.
Thank you very much, Benedetta, for this enchanting presentation. We have time for one question, then I would like to open the discussion with the two of the speaker and the whole audience. I see a raising hand by Surain there.
Test. Excellent. Okay. Thank you, Benedetta. I was listening very intently to your presentation because it's amazing to see some of the methodologies that we've explored in academic research being applied in practice. And similar to the abiotic suitability was something that I also explored in my research, so we will talk after this.
Yes.
But I will ask you the same questions that I received. And they're mainly related to two aspects. The first is the temporal aspect of vegetative growth and animal species interactions. Is this something that is being computed also in your processes? How do you deal with this? Is it through external expert software from ecology? That's one aspect, and the other is the validation of the results. When we say that it's improved, that you bring in new hedgehog species, is there some sort of empirical exercise that you do, or is it compared to existing computational studies?
So, for the first question, so I would say that the timing is actually, so that is a good question also, because when we were talking about the animals, they were saying, so their answer was, okay, you're basically creating a model of the behavior of an animal, but they are adapting so fast to the changes in the environment that is really difficult to actually map the behavior. So that was something that we tried to create in a way that could be adapted in the future. So if we understand that there are some changes, and if we are lucky enough to have some project where we can do a monitoring, that would be something very important to understand. And in terms of the vegetation, we did some, let's say, step simulation. So trying, if we are ideally planting some plants from the very tiny little ones, then we are trying to understand what could happen in different stages. And for the second one, I would say that the improvement is theoretical, the result that you have seen. Also because in the Netherlands there is a huge data set for municipality, and whatever you want, there is a data set that is free to be used. So hypothetically we know that is a computational part, but the outcomes of the project on the existing building are actually put in place, so hopefully we will have some feedbacks on that too in order to validate the model. So yeah, the improvement is basically theoretical one coming from the model.
I've seen a lot of raising hands, so maybe we could start with Lisa and then Yasha.
Yes. Thank you, Benedetta, for the very nice talk. I also have a question, mainly where do the parameters for all the models come from? I mean, mostly I'm interested in the connectivity models, but I think it's in general with all of the models, how do you know, for example, how easily will the squirrel cross the street, or how suitable is, I don't know, X degrees of temperature for a worm?
Yeah, so all the models that we created were coming from different specialist feedback. So all the models come from experts that we have in Arup or external ones. So when we started to develop the tool, so at the beginning it was just a tool for ourselves, so it was mainly related to the expertise that we had, so mainly landscape designers. When we brought that to external clients, then we asked for validation to animal behavior specialists and also to ecologists for the plants. And obviously when you're working with a model that talks about the behavior of an animal, it's not that easy to approximate. So we already have some models that we use for human behavior in movement in spaces, and that was the basic starting point for the development. So we adapted that in a kind of a way to squirrel, to animal, and also for the connectivity model, then we try to do with image recognition, trying to understand which were the green corridors, and then according to that we knew from the animal behavior specialist how more likely is a squirrel to use a green corridor rather than a concrete one. So that was like giving some weights to prioritize the corridors, a corridor rather than another.
And then just a brief follow-up question. Do you then somehow quantify certainty? Do you say, okay, what happens if we change the value by 20%, and then we can also give the clients an estimate of how certain our results could be?
Yeah, so there are some, let's say, uncertainty related to the model. And also we tested with some kind of, so as you saw before, that there was this infrastructure that was kind of blocking a corridor. And we were also trying to test with some new interventions. So we were trying to create a green corridor out of that. And actually that was not successful, because basically all the entire surrounding of the area was basically made of concrete, so it was very difficult. Even if the corridor was created there, it was difficult for the squirrel to come there. So of course we have some uncertainties related to that, and also like the image that we saw about the corridors was basically a probability for a squirrel to prefer a certain path rather than another.
I'll be short. Thank you both for inspiring presentation. I have a question for both of you. In many of the academic research, you heard that we had a challenge with human reaction to animals, and it's quite strange that none of you ever mentioned, the fact that there is such a problem in your research. I mean, when you showed us the bats and all the birds and everything in your project, there was no mentioning of a potential problem. So I wonder if you were exposed to that or just omitted from this presentation.
No, honestly, I think it's a given that the animals have to stay out. I think that's it's not really a part of the discussion. I think the moment it's about buildings. In parks or in the landscape project that I showed, this conversation is easier to have. I would say we have the same issue. It's just that it doesn't even make it really into the conversation, I think. Yeah. At least for residential projects, it would be a niche thing.
Yeah, so similarly, I would say that probably for the Harbour Bank, since it's an office, that wasn't probably that much problem. I'm not sure about the Habitat Real, so that the new building, but I would say that also that was a kind of a driver from the very beginning, so probably it's one of the selling points of the project, so probably also the people that is willing to live in that environment knows that from the beginning, so maybe that was not on the discussion table, but I wasn't there, so I don't know that. But.
No, I think there are two possible starting points, I guess, to look, and it came up earlier in a way in the conversation. Like you said, you focused on residential buildings because that's the biggest building stock. What we realized, for instance, with the rooftop study, we also started with residential, but at some point, in a way, for this kind of change, the most important is to start with one big stakeholder, right? So the residential is a big percentage of the city, but it's very fragmented in terms of ownership. So for instance, I could imagine also with acceptance to animals, public buildings, usually the city starts, or is, at least in the Netherlands, is most innovative with its own building stock. Like for instance, I think all the rooftops of the municipality are already covered and activated, because that's also how they achieve their own targets that they define. The first 20% or whatever they own is easy. So I would imagine also for the acceptance for animals, pilot projects could be found by engaging with public buildings, retrofitting those, and potentially big industry that owns also large buildings and has some either PR value or corporate identity value that they can get out of it. To create acceptance amongst private homeowners, I think is probably quite far down the road, just simply because of the risk mitigation.
Hi. This is on? So I'm the animal model. Hi?
Yeah.
Okay, so I'm Lisa's partner where she does the connectivity model and I do first energy models of animal movements on the bullring. And so I have a question about your habitat suitability models. One of the reasons why we are looking at the actual energy equations of how the animals are moving, locomotive costs and their feeding rates, which come from empirical data, is so that we can also look at things like the fragmentation of resources as well as the quantity of the resources. And I see that and also the interaction between the animals as it is a basic form of competition, but we do have a basic form of competition. And my question is, how are you using, because I know how I would do it, but I'm wondering how you're doing it with just habitat suitability maps that don't have biological interactions within them.
So I would say that basically they were kind of different models that we did together. So basically the final score that we got was not an average, but was coming from the results of the different models and also prioritizing them. So in terms of, for example, the physical model, in terms of sun radiation and wind and whatever, we were mostly focused on the vegetation part, and also for the movement of the animals, that was another one. So they were, let's say, different models that were converging at the same time. So even like the let's say, the competition between animals, that was not taken into consideration. So that was like the willingness of the animals to live in a specific habitat with some conditions. So I would say that if there is that amount of temperature or that amount of type of vegetation, that would be more likely, more attractive, I would say, for the animal to come.
Okay, so there's no biological feedback going on within the models. And what about did you do like a filter process with the habitat suitability of the animals to make sure that the suitable habitat of plants was large enough for them to
so also the dimensions, also the dimension of the areas and the green areas, I would say, was related to the typology of the animal. So it was, let's say, they were different kind of models that were converging together to get a score, but at some point they were sharing information. And I can also say that listening to your presentation, that was a research, and it was super detailed in terms of study and in terms of background research. For ourselves, it was a way of trying to assess the suitability of a space for animals and to improve the biodiversity. So I would say that probably the model is not the most and the best one in terms of showing the behavior of animal, but it was like to give a picture and to give a qualitative insights about the behavior of the animals or the vegetation.
Okay, Katja make a significant sign. So that means that now we have time to enjoy our aperitivo. But before this, I would like to thanks again the two speakers that provide really